I am still working on transformers. Please understand, I have not given up by any means. Gone back to the Mr. Preview experiment. It seems very critical indeed. And this enormous ferrite core in the background is one of that welding lot I got off eBay from an old welding company. Got a bunch of those, so I hope to be able to make use of them. Got the same lovely tank circuit going here, oscillating between the transformer and these two globes. And the third globe is, of course, measuring the input power to the tank circuit. There's also a resistor on the output, just to protect the audio transformer that's driving it. So, next job is, of course, to hook up some power to the inductive, to the induction-free coil, which I'm currently measuring. So we're getting some nice resonance on there, and I'll be back very soon to shift the load over to the primary and see what advantage can be gained. So, do come back. Okay, I'm now driving the primary coil instead. No action whatsoever. But then, of course, it is a non-inductive coil, so that's what's supposed to happen. Nothing. However, I'm hoping at high frequencies it will allow the core to still ring and be non-inductive. I've got the light bulbs shorted out, and there's absolutely no way they're going to glow because the voltage across the bucking coils is, as you can see, about 20 millivolts, 15-20 millivolts across the bucking coils. But I've had to turn the and interestingly, actually, now that I mention it, it's completely negative offset. Despite the fact that it's a resonance wave, the resonance is all in the negative offset region. It's all below zero, which is very strange. So, whenever I notice anything else, I'm going to record it. Good for prosperity and good for reference. I reference a lot of my own material to help me solve problems, and that is indeed very helpful historically. So, I shall continue. Right, now that is what the signal actually looks like across one of the bucking coils. What I was measuring before happens to be the mains voltage. I just want to say there are two possible conclusions. Either this doesn't work, or I don't know how to make it work. But currently I'm trying frequency sweeps from 50 Hz to 1 kHz. So, next plan of attack, I'm going to try and run it all the way up to 100 kHz, the limit of these cores, on a good day, and then try the most likely outcome, which was square waves and varying duty cycles. So let's see. Well, AC current yielded no results whatsoever. I ran a sweep right up to 100 kHz from basically 0, 50 Hz, and no results whatsoever. Output on the scope was nominal at 0. However, I recommend you don't watch this. In fact, I really recommend you don't watch this. But of course, it's completely critical. I'm now running a frequency sweep from 2 kHz to 100 kHz with DC current and a 5% duty cycle. And I've already done this, and I've noticed there are some very strange patterns in there. There are some odd results at various frequencies. These are results I wouldn't have expected. Really quite peculiar indeed. So I'm just going to let it run. We're currently up to 700 kilohertz. Oh, sorry, 70 kilohertz and 75 kilohertz, and we're looking for 100k. So there are resonant patterns, there are pulse trains, all manner of strange patterns in there, and hopefully something in there that can help us. There's certainly a lot to choose from. So while the camera's off, I'm going to run a very slow frequency sweep by hand and have a closer look at some of the targets. And yeah, and when I've determined that there's something very interesting in there, I'm going to come back and show us. But we're at 93 kilohertz now, and I'm going to cut the camera off when it hits 100. Still not enough amplitude to produce any light. It must be added. The scale on the scope is 100 millivolts. So as far as I can tell, the best we're getting as far as output is half a volt. And the input voltage is 45 volts. And that's the end of it. At about 300 milliamps. 45 volts at 300 milliamps. So keen maths fans, that's about 15 watts. But obviously that's all resistive, because this is a non-inductive primary. A non-inductive primary and 2 bucking coils. So 15 watts of purely resistive load. Alright, let's see if we can find something in that matrix. Thank you very much. Well, this is fantastic news. I know it looks like a bit of a mess, but that's because I've pushed the frequency beyond what what my transistors are capable of. I'm all the way up to a very humble 42 kilohertz, and sadly it's no longer putting much power through these transistors. But anyway, what I have noted is that I'm getting some of the most beautiful resonant oscillations through this transformer that I have ever seen. The transformer is ringing like a bell, which is interesting because this is a completely non-inductive coil. So I'm getting some really vigorous, powerful responses from this transformer, despite essentially putting no conventional power into it. So it's all resistive. So that's magnificent. I wonder if it's worth sticking a magnet in there and getting that to vibrate the coil. Food for thought. But I shall continue. Hopefully more amazing discoveries tonight. Beautiful, huh? These are the DC square waves. I've dropped the duty cycle down to 1%. And this core is ringing. I thought you'd want to see what it looks like. There you go. She's a beauty. And some back-to-back diodes. It isn't dropping too heavily under resonance. So we shall see what that means. ...